Section 5.4 is about the irrational numbers, and this is part 1 of a 2-part video. It is a longer section, and that prefix IR means not. These are not rational. They're the opposite of the rational numbers. So if you think back to our rational number video, we defined them as they're fractions that create two different types of decimals. They created terminating decimals, meaning decimals that ended, and they also created repeating decimals that repeated the same pattern in the decimal portion forever. So it just makes sense that irrational numbers are the non-terminating and non-repeating decimals, since they're the opposite of rational numbers. What we mean by that is these are just random decimals that never ever end. When I say random, I mean that there's no pattern to what's in their decimal spot whatsoever. So let's look at some examples on the graphing calculator of how we can tell when we've typed in a number if it's irrational or rational. So here are some examples of irrational numbers. The square root button on the graphing calculator is located right above the x squared. So to access it, I need to hit second, then the x squared. And you'll know you've done it correctly because that square root symbol will come onto the main screen. So if I type in like the square root of 2, right arrow key to get your cursor out from under the square root symbol, enter. You can see what I mean by this is just a random decimal that never ends. Random in that there's no pattern to it. It does not repeat the same pattern. I mean, I do see a few 4s and a few 2s and a few 1s, but there's no pattern that's repeating, and there's no pattern at all to this decimal. The calculator can only hold so many digits, so it's going to round that last digit, but honestly, we could make a guess from how long this decimal is that it never ends, truly. So that means square root of 2 is an irrational number. If I try square root of 3, second, x squared, there's that square root symbol, 3, right arrow key, enter, that's also an irrational number. The calculator had to round that last digit again. It's just a long, never-ending, just random decimal. However, square root of 4 comes out much nicer. Square root of 4 is just 2, so square root of 4 is a rational number because it's a decimal that technically ends, because I could rewrite 2 as 2.0. So square root of 4 is just a nice rational number, whereas square root of 2, square root of 3 were irrational numbers. Numbers like pi are irrational. Pi is located above this up arrow. So if I hit second up arrow, there's the number pi, enter. There again, just a long, never-ending decimal, random, because no pattern to it, so that's an irrational number. There's a number we're going to be using a bunch when we hit the financial math chapter, and that's E. It's behind the division button. So if I hit second division key, enter, E is a number. It's not a variable like x was in algebra, and it would round to about 2.72, but it is a rational number in that there's no pattern to it and it never ends. I'm going to go ahead and jot down those examples of irrational numbers. So I'll write EX, for example, here. We said square root of 2, square root of 3. A lot of the square roots, but not all of them, because remember we saw, for example, square root of 4 was not an irrational number, it was rational. But square root of 2, square root of 3, the number pi, the number E, etc. So working with these, looking at example 1, it says to simplify if possible. The problem in math with working with irrational numbers is we don't want a rounded answer. We want an exact answer. So we're not going to look at the decimal answer. We're just going to look at how we can simplify that answer, and often we're going to be stuck with a square root symbol in the final answer. So like A, says 7 times the square root of 28. And I can always assume that multiplication is implied whenever you have a number like 7 here that's just hugging up close to that square root symbol. So the first step to simplify this number, and by the way, you're going to have the same exact decimal number represented at the end of this. When we say simplify, it means, is it possible to kick out part of the number from under the root to in front of the square root symbol? So we have a simplified square root number. But again, it's still going to represent the same exact number in the long run. So your first step when you see these directions on the homework is to draw a good old prime factor tree for whatever number is under the square root. So I'm not worried about the 7 in front of the square root yet. I'm just worried about that 28. So whatever's under the square root, scoop it up. Start with any pair besides itself and 1 that when multiplied together gives you 28. I'm going to go with 4 and 7. You can use 2 and 14. You can use any pair as long as it's not itself and 1. And circle once you have a prime number, that means that branch is done. So 7 is prime because it's only divisible by itself and 1. However, 4 is going to break down further. 4 is not prime. 4 is 2 and 2. So I could rewrite 28 as 2 times 2 times 7. I only look at the circled prime numbers is all we care about. And how we know we can go further, we can simplify this, is if we have a matching pair of the same number in the factor tree. And I do. I have a matching pair of 2's. So that means, unfortunately, we can go further. So I'm going to bring over the 7. And bring over the square root symbol. But 28, I'm going to rewrite as, look at your circled numbers, 2 times 2 times 7. Did not use the 4 in the tree, just the circled numbers. For every matching pair of numbers, this is why I say for every matching pair, that's how you know you can go further. With a square root, every matching pair of numbers, you're going to kick out one of that number to the front of the square root symbol. So when I say kick out in front, I mean multiply in front of the 7 in this case. So if I have a matching pair of 2's, that means that one number 2 is going to come out front and it's going to be multiplied by the 7 that's already out front of the square root symbol. And I put a dot for times. Why does this little trick work? Why for every matching pair I kick out just one? Well, if you multiply those numbers back together, 2 times the 2, that really represents 4. So really, I just did the square root of 4. What's the square root of 4 equal to? Meaning what times itself gives you 4? 2. So square root of 4 is 2. And when you have just multiplication under your square root, you're allowed to kick numbers in front. You're allowed to apply the square root, in other words, to the numbers underneath it. So, matching pair of 2's, I kick out one number 2, meaning multiply it in front of the square root symbol. And now let's just keep going with the simplifying. So now I have 2 times the 7 in front for 14. Because remember, the dot here is for times. And what's left? What are we stuck with under the square root symbol? Well, we're stuck with a 7 because 7 had no matching pair. So 7 times the square root of 28 simplifies down to 14 times the square root of 7. Just to show you what I mean that we didn't change the number at all, the original number was 7 times the square root of 28. So let's type that into the calculator to see what number we were actually working with. So 7, and honestly, you don't even have to type in the times symbol. You can just go right to the square root symbol, which again is above the x squared button. So second x squared, there it is, 28. Right arrow key to get the cursor out from underneath the square root symbol. Enter. Definitely an irrational number. It's just a decimal, a yucky decimal number that never ends. The calculator had to round the last digit. Random, no pattern to it, does not repeat the same pattern. So that's what we started with, and now let's type in our final simplified answer, which was 14 times the square root of 7. So 14 second x squared for square root again, 7, right arrow key, enter. See, it's the same exact yucky decimal number back again. It's just simplified, we say in math, because I was able to kick out part of the 28 to the front of the square root symbol. I was allowed to apply the square root symbol to part of the number 28, in other words. Let's try one more. So looking at B, this is all example 1, same directions, simplify again. It says 3 times the square root of 52. So step 1, for any square root symbol you see in this week's homework, to simplify it, you got to draw the factor tree to see if it will indeed simplify further. All we care about to start is the number under the square root symbol, which is 52. And pick a pair, any pair other than itself and 1. That gives you back 52. I'm going to go with 2 times 26. 2, that branch is done. 2 is a prime number. 26 goes down further. 26 is 2 times 13. And we know we can go further if we have a matching pair of the same number that's circled there on the factor tree. And we do. It just happens to be the number 2 again. So we bring down the 3 in front, but I'm going to rewrite 52 using just the circled numbers. So it's 2, check, times another 2, check, times 13. And if you're not sure if you've done it correctly, multiply 2 times 13 back again, and you see that you do in fact have 52. For every circled pair, kick out 1 of that number in front of the square root symbol. Since 2 times 2 is 4, we're really just doing the square root of 4, which equals 2, is why we kick out 1 of that number, why that little trick works every time with the square root. And we multiply it by any number that's already there. So the 3 in front times the 2 you've kicked out is obviously 6. Bring down the square root symbol. We're left with a 13. So our final simplified answer is 6 times the square root of 13. Looking at example 2, it says to perform the indicated operation, simplify the answer when possible. So example A here, part A, says to multiply. And what's nice with multiplying these square root irrational numbers is you do not have to have the same number under the square root symbol. You just can mush it together. So any numbers in front, multiply those together. Any numbers underneath the square root symbol, multiply those together. I have square root of 5 times 3 times the square root of 50. The square root of 5, we can assume, since there is no number in front, that there's really a 1 in front is implied. Here we go. So we keep like with like. So I'm going to do 1 times the 3, which is obviously 3 is our number in front. Square root, now we keep the numbers under the square root symbols together. So I have 5 underneath the first square root symbol, times 50 is underneath the second one. 5 times 50 gives me 250. So I've done the multiplication step. That was easy enough. Now, step 2, we simplify just like we did on the previous slide, where we draw a factor tree to see if we can go further. So this time, the number under the square root is 250. Doing my factor tree over here, pick any pair. When multiplied together, gives you back the 250 other than itself and 1. I'm going to go with 10 times 25. 10 breaks down, of course, into 2 and 5. And 25 is 5 and 5. So all my branches end with circled prime numbers is how I know the factor tree is done. And we said we can simplify our square root number further if we have a matching pair of numbers. And we do. We have a matching pair of 5s this time. So I'm going to rewrite the square root symbol. I'm going to bring down the 3 that's in front and the square root symbol, leave a little bit of room between the 3 and the square root symbol to kick out some numbers. And you're going to rewrite 250 as 2, check, times 5, times another 5, times a third 5. For every matching pair of numbers, kick out one of that same number, meaning multiply it in front. So if I have a matching pair of 5s, one number 5 is going to go in front, and it's going to be multiplied by the 3 that's already out there. If you're going, why does that trick work? Multiply those 5s back together. 5 times the 5 was 25, and when you do the square root of 25, that gives you 5. So we have 3 times 5 for 15 in front. Multiply the remaining numbers back together under the square root symbol. So I have a 2 times this 5 over here for 10. So my final answer, I'm circling it in black, is 15 times the square root of 10. Looking at example B, we see a fraction bar, which means division. Square root of 54 divided by square root of 6. Since both numbers are under a square root symbol, I am allowed to divide them. And I'm going to start off with a square root answer. So square root of 54 divided by square root of 6, take the 54 in the numerator under the square root symbol there, divided by the 6 in the denominator under the square root symbol. 54 divided by 6 gives me 9. And we brought the square root symbol over as well. Keeping like with like again. Square root of 9, well, you could do a factor tree for it to see if you could simplify further. But we know what the square root of 9 is. It's just 3. In other words, what times itself gives you 9 back again? 3. So our answer ends up being a nice rational number for a change. Now, let's say that you forgot and you did a factor tree for 9. So 9 is 3 and 3. You can go further because you got a matching pair of numbers. So you could have rewritten 9 as 3 times 3. You would have said, okay, I got a matching pair. I'm going to kick out 1 3 in front of the square root symbol to represent the matching pair. But the difference between this example versus the others is that nothing is left under the square root symbol. So I brought down my 3, but you have nothing but air left under the square root symbol. When that happens, you don't need to keep the square root symbol. Just keep the number in front, since we've applied the square root symbol to everything underneath it. And as you can see, doing it the long way with a factor tree, you would still get 3. So regardless if you just recognize, hey, I can do that square root without needing a factor tree to simplify it, or if you forget and do the whole big long factor tree, it doesn't matter. You're going to get 3 is the good news either way. Example 3 says to rationalize the denominator. If you look at A, B, and C, even though they're fractions, even though they're division, they're very different than the example we just did on the previous slide because the numerators are not under a square root symbol in A and B anyway. So that means we need a different approach. I cannot take 25 divided by 10 in A because 25 is not under a square root symbol, whereas 10 is. So they're different types of numbers. So that's why they have this new vocabulary, rationalize. And rationalize describes a process in where we're never ever allowed in math to leave a final answer with the square root symbol on the bottom of a fraction. It's not proper notation. So we need to figure out a way to get rid of that square root symbol. It's okay if it's on the top of a fraction, we just can't leave it on the bottom. So rationalize describes the process, how we are guaranteed to get rid of that square root symbol from the bottom of the fraction every time. And that process is whatever square root symbol is on the bottom of the fraction, you're going to multiply the top and bottom of the fraction by it. So like A, if I have square root of 10 on the bottom of the fraction, I'm going to times the bottom by square root of 10. But whatever I do to the bottom of a fraction Got to do it to the top of the fraction as well. So I'm also going to multiply the numerator by square root of 10 as well. So again, whatever square root symbol is on the bottom, multiply the top and bottom of the fraction by it again. Now it's just a matter of simplifying. So on top, I have 25 times the square root of 10. I just mush it together because 25 is not the same type of number as square root of 10. 25 is not under a square root symbol, so that's why it stays in front of the square root symbol. On the bottom, I can combine these because both 10s are under a square root symbol. They're the same type of number. So if I bring over the square root symbol, I can do the 10 times the 10 for 100. Let's keep going, see if we can go further. So I have 25 times the square root of 10 on the top. On the bottom, the square root of 100, well, I know what that is. I don't even need a factor tree. It's just 10. Because square root means what times itself gives you back 100. Well, 10 does. So see how this little trick worked? When I took a square root and I multiplied it by the same exact square root, by the end of it, the square root symbol ends up going away. So I ended up with just 10. Bye-bye square root symbol. Let's see if we can go a little bit further in the numerator. So let's look at the number under the square root symbol up there. Up here we have a 10 under the square root symbol. I'm going to draw a factor tree to see if I can go further. 10 does break down into 2 and 5. However, we would only be able to simplify this square root further if I had a matching pair of the same number, and I don't because I have 1, 2, and 1, 5. So square root of 10 on the top there is not going to go any further. The only thing I can do is look at the numbers that are not under the square root, because I have a 25 divided by 10. And that fraction is going to reduce further. If you do 25 divided by 10 on the calculator, and then math button, enter, enter, remember that's how we reduce fractions. We talked about that in an earlier video. 25 tenths reduces to 5 halves. So I'm going to write equals 5 halves, and then just bring the square root of 10 down. It's in the numerator, so it's going to stay in the numerator. So there we go. Our final answer for A is 5 times the square root of 10 divided by 2. It is rationalized because the square root symbol, we got rid of it from the bottom of the fraction, and it ended up on the top of the fraction by the end of the question. Looking at part B, we got 15 divided by square root of 12. So to begin to rationalize, we look at the square root on the bottom. It's a square root of 12, and we're going to multiply the top and bottom by square root of 12 then. So on top, we got 15 times the square root of 12. They're different types of numbers, so mush them together. Whereas on the bottom, they're the same type of number. The 12s are both underneath the square root symbol, so I can combine those. Bring over the square root symbol. 12 times 12 gives me 144. We can see why this little trick works because the square root of 144 is just 12. So after we multiplied out the bottom, there's no more square root symbol left. It's just 12. You might be noticing a pattern emerging. Feel free to skip some steps by using that pattern. In A, we saw that square root of 10 times square root of 10 gives you just 10 in the long run. In B, we saw square root of 12 times square root of 12 gives you back just 12 in the long run. So square root of 2 times square root of 2 would just be 2, and so on and so forth. So square root of a number times square root of that same exact number equals the number back again without the square root symbol. Let me go ahead and just rewrite this 12 a little bit nicer. On the top we have 15 times the square root of 12. Resist the urge to cancel out these 12s because they're different types of numbers. One 12 is under a square root symbol, another one is not. So I cannot touch whatever's underneath the square root symbol if no other part of this number is underneath the square root symbol. It's stuck under the square root symbol. But what I can do is ask myself if this is going to simplify further. The square root is going to simplify further by drawing a factor tree. So currently under the square root is a 12. If I do a factor tree, I'm going to pick 3 and 4. So 3 is done, that branch is done, but 4 goes down into 2 and 2. I do have a matching pair of 2, so that means that the square root can be simplified further. So let's bring down the 15 that's in front of the square root symbol, leave a little bit of room, and you're going to rewrite 12 using just the circled numbers. It's 2 times 2 times 3. And on the bottom, just bring down the 12 that's still there. For every matching pair of numbers, you're going to kick out one of that number. So if I have a matching pair of 2's, one number 2 gets kicked out to the front, meaning multiplied in front. Go ahead and times it by the 15 that's already there. So I have 15 times 2 for 30. Stuck under the square root symbol is a 3. And go ahead and just bring down the 12 that's on the bottom. Last step, now that you've simplified the square root number, is to see if the numbers outside of the square root symbol will reduce down. I got 30 divided by 12. I'm going to use my graphing calculator. I'm going to type it in. 30 divided by 12, math button, enter, enter. And that does reduce to 5/2. And just bring over the square root of 3 that's on the top. So my final answer, 5 times the square root of 3 all over 2. To summarize the steps, whenever it says rationalize, there were 3 steps. Step 1, you multiply the top and bottom of your fraction by whatever square root is on the bottom of the fraction. Step 2, after you multiply across the tops and the bottoms, you see if the number under the square root, when you draw a factor tree, if there are any matching pairs, meaning can you simplify the square root number. Step 3, you look at the numbers outside of the square root. We had 30 over 12 this time, and you see if those reduce any further. So most of the work with these honestly are the simplifying steps 2 and 3. Looking at C, I had to draw a little wobbly black line there to separate my work because my handwriting's so big. But I do have just enough room. C, we got square root of 2 7s. This one's a little different because the 2 and the 7 are both under the square root symbol. So whenever you have the square root of a fraction, you can distribute the square root to the top and bottom. So this is square root of 2 divided by square root of 7. You could try to combine these numbers. They're the same type of number, kind of like the last example on the last slide. But 2 does not divide by 7 evenly. So we're going to go ahead and rationalize. Do the same steps we've been doing with A and B. So I'm going to times the top and bottom by the square root on the bottom, which is square root of 7. And this is done to get rid of the square root. Keep in mind that's on the bottom of the fraction. So on the top, we got the same type of number, so we're allowed to combine them. We got a 2 times a 7 for 14, so I got the square root of 14. And on the bottom, square root of 7 times square root of 7. Well, if you remember the pattern, it's going to give us just 7 without a square root symbol. Why? Because 7 times the 7, both under a square root, is 49. So I really got the square root of 49 on the bottom. So writing that in, I have just enough room here. So we got the square root of 14 on the top over square root of 49 is 7. Then step 2, see if the square root number that's left on the top will reduce any further by drawing a factor tree. If I draw a factor tree for the 14 that's still under a square root symbol, that's 2 and 7. I do not have a matching pair of numbers, so it's not going to reduce down any further. Step 3, check if the numbers outside of the square roots are going to go down any further. Well, I have a 1 that's implied in front of the square root of 14 over 7. That's not going to reduce down any further because only 1 divides into 1 and 7. So my final answer is just square root of 14 all over 7. I'm circling that with my black pen right now.